Good afternoon, everyone, and welcome to this training session. This is part of a competition organized by the European Space Agency's Climate Change Initiative Knowledge Exchange team. So we're organizing a competition focusing on forests in a changing climate. So it's a data visualization competition for which we are having a training today. So I will begin to tell you how this session will be structured. So we will begin with a little bit of background on what ESA's Climate Change Initiative is doing, and a background on the data that the Climate Change Initiative is producing, and introduce you to the training environment that we will be using today. The way this training will be structured, we'll begin with a little introduction of what the Climate Change Initiative, CCI Knowledge Exchange team is doing, a little bit of background on the data that we have. We will introduce the CCI toolbox. So the idea will be to show you how to use biomass data and other type of data relevant to the competition challenge. And for this, we will be using a tailored environment that we have developed using Jupyter Lab. So you will be introduced to this environment, how to make an account, and this platform you will be able to use for the competition to access the data, compute it, and then do your own visualization. So we will have roughly 1 hour to look at the notebook that was prepared for this training. So the idea with this notebook is to understand how we can access various types of CCI datasets and plot them. And then you will have a little bit of time to work on this. And after this, I will introduce you the competition challenge and the guidelines. And to end, last but not least, we will have a small presentation by our communications team who will talk about good practices for effective science communication and storytelling. So we have a packed agenda for 2 hours, but it will be mostly interactive for the tutorial part. So hopefully we'll have time to exchange and we'll have time to look at your questions and answer any issue you have using the Q&A box and not the questions box. So thank you all for joining, and we can begin now with the background of our activities. So the Climate Change Initiative training activities are targeted towards a large number of people. So it's early career scientists, for example. It's also subject specialists. We have seminars that we do regularly to show the latest science that CCI scientists have done using the climate change data that is produced within the ESA CCI team. We have also events targeted to policymakers, science communicators. We've done a few events in the past in different type of conferences, such as the United Nations Ocean Conference and also the Living Planet Symposium one. We have done lots of training events, so that's using Jupyter notebooks to show basically how to use the data that the ESA CCI team is producing. And to encourage people, either scientists or people working in policy, science communication, how they can apply it to their specific areas of interest and expertise. And also we have competitions. So this one that we are preparing is our first competition. It's focusing on forests. We decided to do a competition that will focus on this because of the upcoming COP30 happening in Belém in the Amazon. And so we thought it would be a good idea to invite data visualization enthusiasts to use the data sets that we provide and think of a good idea to communicate important messages in relations to how forests are impacted because of climate change. And so that's the purpose of this training, to show you which relevant data you can use for this. And then apply it for your own submission if you wish to join the competition after this training. So I talked a lot about the ESA Climate Change Initiative datasets. So these datasets are actually responding to the Global Climate Observing System, which defines a series of essential climate variables. So these are either physical, chemical, or an ensemble of variables that describe the climate system. And so the rationale behind the Climate Change Initiative is to provide a long-term, robust time series of these ECVs using satellite data. And so far, the Climate Change Initiative has produced 27 ECVs, and so they are all available on the climate.esa.int website. And you can see here it's all the variable that we have and that you could use for your visualization that you will do for the competition. And so there are lots of projects that are also ongoing, which are looking at cross ECVs applications, such as climate and health, climate and cities, for example. And so we invite you to look at the website to learn more about what ESA is doing and the activity that are coming for the next ECVs projects. So to create a climate data record, what we do is piecing together a series of individual satellite sensors to create a long-term climate data record that is robust to see how climate is changing across the years. So here, for example, it's the ensemble of sensors that were used to compute the land surface temperature ESA CCI dataset. And if you want to know more about how the other data were computed, we invite you to look at the website. So we have an open data portal that is that offers free and easy access to all of the ECVs. So you will see there are different type of products for each of the project. And so based on your application, you can choose the more relevant one, and there are detailed description for each of these products. So most of them span, as you can see, at least 10 years, which is essential to look at climate applications, to have as a large number of years as possible. And so this is the website where you can find them. And here in this session, we will show you another way to access them. So on this website, you could download them directly on your computer in .NET-CDF format for most of them. But with the training environment that we have, you can access them in a more rapid way in a simplified format. And we will talk more about this later. So before going straight into the training, I just wanted to mention very briefly a few examples of why these ECVs matter for studying climate change. So here we're looking at a map of land surface temperature. So it was in summer 2023 when a heat wave was happening across Europe. And so we can see here data from Sentinel-3 missions. And so what the ESA CCI is doing is combining, as we've seen in this image of the multiple sensors, it's combining different results of the different sensors, different images, sorry, of the different sensors, and combining them in a long time series. And so we have, for example, here a new project that is the land surface temperature dataset that spans 25 years, and it allows us to have an idea of how land surface temperature is changing across the globe as a response to global warming. So it's a good data set for monitoring land heat wave from space. And so there are lots of studies that are ongoing and have been done to look at how heat waves have changed in recent years. Another application is also, which is more relevant to the subject of the training, is monitoring changes in the carbon from space. So there's been a new dataset that was released recently, which is an above ground biomass dataset, which which makes possible today to have a really robust overview of how biomass is fluctuating at a global scale. And so this allows us to have an estimate of how the carbon stocktake is changing around the world. So we'll talk a little bit more about this dataset. In fact, we'll show you how to plot it, how to access it on the training environment. And so before we do this, we will introduce you to a Python package that was developed by the Climate Change Initiative. And so for this, we have Tonio that will introduce us to this package. So Tonio, the floor is yours.
Yes, okay. Thank you, Amina. And also quite happy to see so many people participating here. So many people interested in the toolbox and accessing the CCI data. So I guess best thing to describe the toolbox, which many might not be yet familiar with, is that it is um, basically one Python package which serves two main purposes. The first one is that it gives you access to the CCI data that Amina had shown in the on the previous slide and explained. And the second purpose is to give some operations, to provide operations to operate on these data. So there is already a vast array of them. So there's operations for detecting anomalies or for performing some geometric pre-processing things like co-registrations or general resampling. And there are this is all also explained within the documentation. If you can just go back one slide, the other direction. Sorry, yeah, because I just wanted to briefly point to the link at the very bottom. That is to the documentation of the toolbox, where you can find quick start guides. There's it is also explained there how to install the toolbox on your local system, which some of you might find also convenient. And also there is the API reference. So it is explained in detail on how you can access data, but also it lists which operations are provided, what you could maybe use for your works. And yeah, it also lists there which parameters are available. So for installing the toolbox, maybe it's just of interest that this is an open source project, and you can download the code directly from GitHub if you want. But I think for your purposes, or most people will find it most convenient to use a package manager like pip or conda. So the toolbox is available from these two. Okay, I think now we can move on to the next slide. And so to say a bit more specifically what the toolbox will offer when you want to access the data is that you can just say what is the ID of the data that you're interested in. There's also there are also methods to get all these IDs, and you can see what data is available for a distinct ECV, like cloud, fire, biomass, whatever it is that you want to use. And then the data is provided either as an X-array data set or as a GeoPandas geodata frame. So all the data comes usually with a spatial component and also a temporal component. So it has it's basically these spatial temporal data, which comes in these well-supported formats that for which you can also use any other packages on a technology stack that you might find helpful. Most data is gridded data, so it will come in the form of the data sets, but as I said, there's also the geodata frames. In our example, later we will mostly work with the data sets. So on the right there's this one image where you see how this geodata frame would look like. That's for greenhouse gases, I guess. And what visualization at the very, very basic level could look like. So what you have at hand there. And next slide, please. Okay, so there's one more thing to say about the provision of the data. Amina had already mentioned that most data is provided as a netcdf on the ODP, and this is the data that is usually accessed through the toolbox. So we are trying to hide this layer away from you, so you don't need to open all these individual netcdf files, but all you need to do is to say this is the idea of the ID of the data set that I'm interested in, and you will get this one single, usually X-array data set. But we had also worked on making this more performant to use. So there are two extensions to the system. One is that there is what is called here the Kerchunk reference data store, which is an alternative view on this netcdf data. And what should be the takeaway message for you is that this is usually faster to use, and the access is just faster. So in case you have the option to use a Kerchunk store, you should use that. And basically, if we have all the data, we provide all the data from the store at the very bottom, the CCI data store. You provide some of the data, I guess most of the data also as Kerchunk, but not all of them. And then there's that's third option, which is the ZAR store. And this is for some selected data sets, but this is like the best option, the deluxe option, so to say, for some of the data sets. And this is just the fastest way to access data. So again, the takeaway message would be, in case you can use the ZAR store, use it, then Kerchunk would be the second option, and then the CCI store. And I think that sets you up already to go to the training environment now.
Yes, if you could maybe share your screen for this. What we will ask you all to do is to follow the instructions to register on the training environment and then wait a little bit for not make the platform crash, to not compute anything. So for this, Tonio, I think you need to share your screen, so I will stop sharing mine. And maybe if there are any questions already, you can jump in the Q&A, and we will look at them while Tonio is sharing his screen.
Yes, I would do so. So maybe first thing I want to make sure is that everyone has the link to the Jupyter Lab.
Oh, so I will share it again because I don't think they have had time to look at this.
Otherwise, I would just post it.
Yes, it's probably better. So Tony will share the link, but if you want, you can also click on the Padlet link. You can directly scan the QR code, and you will have access to all the documentation that we've talked about so far. Otherwise, Tony is putting the link on the chat, and you can just click on it, and this is where the registration is happening.
Okay, and this is then just quickly to show how the notebook for the competition can be downloaded or cloned into the Jupyter Lab environment. So we'll just log in with my credentials. If you don't have any credentials yet, you can register. And then when I'm signed in, I just go to the Jupyter Hub. I will start a new server. An old one was running. I will start a new one. Just pick any resource allocation here for my purpose. I will just go with the lowest one. I will wait for it until it is fully started up. You can see in the log what are the steps taken or outstanding. Usually just takes a few moments. This is the step that takes the most time. And I can already prepare in the meantime the link that I will require. So we are using the ACT training from GitHub, and this is the link to the GitHub repository that we will actually use. And I see that in the meantime, the Jupyter Lab is available. And what probably you would see in the beginning is that you have here an empty directory, or mostly empty. And to load in a new repository, you can select the Git icon, the third one from the bar on the left. Simply choose Clone a repository. And there's the field where you should paste in the remote repository. So that's the one that we had just selected for the ECT training. For these options here, they don't matter. In our case, you would get the same result anyway. So we'll just clone them. Just hit clone. And it was successful. So now in my folder structure, I have the ECT training. And it's the climate change competition that I'm interested in, where there's just this one notebook that I can open. And here I then have the option, or I need to choose a kernel. And the kernel that I want to use is from the climate namespace, the ESA Climate Toolbox environment. So I click on it. And now I can run all the cells of this notebook. And yeah, maybe just one more word about the kernels. You could basically also try any other one, but this is the one with the latest installed toolbox and other versions. So we recommend to use this one, the ESA Climate Toolbox. Okay, thank you.
Now we will have a look at the Jupyter Notebook, which is basically serving as an example to show you what the toolbox is capable of doing on a very basic level, just to give you some idea of how to use it and how you can visualize the data. We have also added some descriptions in the Jupyter Notebook, which you can then read on your own time. And we also provided you some links to, for example, the toolbox, which Tonio has just presented. If you want to learn more about the operations you can do with it, or how to install the toolbox, for example. Right, so if you are not familiar with Jupyter Notebooks, it's basically a mixture of Markdown and coding. Markdown meaning you can add text or figures like this logo here, for example, and it operates in different cells. And the advantage is that you can add your text and descriptions, and you can also have your code embedded within the notebook. So this first cell here is the first cell with the Python code. And what we do here is we basically read all the packages or call all the packages that we need for this Python code to run. If you want to execute one of the cells, you can either do this by clicking on the run cell button, like the play button, or you can also use Shift and Enter or Control and Enter. The difference is basically Shift and Enter will jump to the next cell, and Control Enter will stick to the same cell. So what we do here is we call all the packages. Up here we start with the ESA Climate Toolbox packages and import different functions from there. You can read what they do here, or then in further detail in the toolbox. And then we also call some packages that we need for working with the data. For example, pandas, numpy, and xarray. And for displaying the geographic regions, which is you can see down below here, we also import the package for IPython display. And then we use for plotting and mapping matplotlib and cartopy. And yeah, here we just suppress some warnings to make the Jupyter Notebook look a bit nicer. So once you have imported all the packages, you can then move on to the next cell. And what we do first here is, just a second, if I can zoom in. Yes, thanks, Amina. Is it better now?
Yes, it's much better.
All right, good. Thanks for telling me. Okay, so yeah, I will once again just briefly show the cell with the packages, which we just talked about. And then we go further to defining a region of interest. Here we can define a bounding box. We are now focusing on the area in the Amazon forest because the competition is about the biomass. And I can basically define the latitude, latitude boundaries and the longitude boundaries. So longitude minimum and maximum and latitude minimum maximum. And with the GeoJSON, you can then show or visualize where your bounding box is. So if I execute the cell, I have an interactive map, and I can also zoom out or zoom in, and we can see where the box is that I have defined here. You can obviously choose a different area. I have also put here an example for a larger bounding box. However, especially for the training purpose, I would advise you to stick to a smaller area because it basically reduces the computation time. Otherwise, you're waiting a long time for the data to be downloaded and visualized. Right, so I have provided you with this bounding box here, which focuses on an area that has experienced some droughts in the past and is basically suffering from climate change and forest loss. And then we can move on, and we'll start with using the climate toolbox. Once again, you have some links here where you can read more into detail if you want to learn more about it. And the first step, if you would want to call different data sets, would be using this, this command list ECV datasets. In our case, we are first interested in the datasets from the biomass. So if I execute this, it will take a little while, and then it will give me a list of all the datasets that are about the biomass or containing biomass data. And obviously you can put in other parameters here. First, let's scroll down here. You can see there's loads of data sets. And as Tonio mentioned before, there's different kinds. There's the ESA CCI store. And we advise you to use the ESA CCI ZAR store because it's much faster. And thus we have two files here and in the highest resolution. And in our case, we will use the very lowest one with the 100-meter resolution covering 2010 to 2020. If you would like to call or look at different data, I would just briefly show you, because sometimes I don't know what to put in here. So if I just put a space bar, it will give me an error, and there's actually a list with all the parameters. And then, for example, if you want to look at fire, you can use fire and retrieve the list of all the fire datasets. Just to give an example how to access the data or get an overview of what is actually available. Right, then there's a lot of data, sorry. Okay, then there's a brief overview again about the data formats, which you can look at in your own time. And now that we have chosen a data set from the biomass data, which is defined here with the data ID, this is ESA CCI biomass with 100 meters, .zar, which shows you which data format it is. And we are also defining the ESA data store, CCI data store, with which we want to retrieve the data. And this is in our case, the ESA CCI ZAR. So I will execute the cell. And now I have defined the ZAR store, data store, and I have defined the data ID. So now it would be good to actually have a look at the data, what is actually contained there, what do we have there. And you can do this by using this store command, CCI store, and then describe data with the data ID. And if you execute this, this is a very nice thing about Jupyter Notebooks. You have this interactive box here, and you can actually click on the arrows and look into further detail about, have a look at the structure of the data. For example, we can see the time range that it covers 2010 to 2020, and even the month and the year, the day. You can look at the dimensions. You can look at the data variables, which is quite important because we want to know what is actually inside the data set. In this case, it is AGB, which means above ground biomass. And those are things that you might not necessarily know, but I advise you to go to the data store from the Climate Change Initiative website. And here you have those links showing you, for example, the product guide. And then you are brought to the product guide of each data set, and you can look things up. Like, for example, here, AGB means above ground biomass. Right, and what else do we have here? We have latitude, we have longitude. Yeah, we have the time, so we have actually everything we need. Another important thing is to know is also the unit, which you find here in the attributes. Yeah, here you can actually see the long name, so you might not even have to use the product guide. And the unit for the biomass is megagram per hectopascal, hectare, sorry. Right. Then now let's open the data set after we have had a look at it. We do this by using this CCI zar store.open data command, and we give it the data ID as information. Here I could, for example, also say display the biomass data set. And then in Jupyter Notebook, you can immediately see the output, and you would once again have some information about the data set, like the time, latitude and longitude, like the dimensions, and which data variables are inside. And you could even click on those containers and get more information, what is inside the latitude and longitude, for example.
Lisa, I think we have a question. Someone is asking, what's the valid range?
The world range?
The valid range? I think you were showing.
Let me see the question. Valid range, what do you mean by valid range? Could you maybe clarify this question?
Just maybe in the meantime, I just got a message from our support that they had increased the quotas. So it probably was too many people trying to access at the same time. So now would be a good time to start again, whether you can access the Jupyter Hub in case you couldn't before.
Should I give you some time, or should I continue? What do you think?
For me?
Yeah, for the participants. Okay,
I think maybe continue.
Just
I can continue.
Yeah. Yes, and then we can take a bit of time to look at everybody's problems with logging in.
All right.
And I will share the link to the repo as requested.
Okay, great. So now that we have defined the subset in the top, where we look at only a specific area of the Amazon, we can now use the subset and basically decrease the data load by applying this to our biomass data set. And for this, we can get the operation from the CCI toolbox. You can, by the way, use the command from ESA CCI toolbox.core import list operations. So you once again import like a package, and then you can use the command list operations, and it will show you what operations are available. And in this case, I'm using the subset spatial, which means basically what it says in the name, you build a subset on the region. Now I have called this operation and I can apply this on my dataset. The dataset is the biomass dataset, which we loaded above, and the region is the bounding box that we defined in the beginning. And I can execute this and will then have a new dataset. Let's once again display this. And you can see that now the latitude and longitude is a lot smaller compared to the previous or original data set, which makes things a lot easier, especially when we are plotting high resolution data. In the next step, I would like to show you how to visualize the results. First up, we will create, so we have like a small area here where we create a folder that will then pop up in your folder area, so that you can have a place where you can save the figures. And then we define a couple of years. In this case, I chose 2018 to 2021. However, the range function functions in a way that it only covers 2018 to 2020. This is like a Python thing. So because I wanted to include 2020, I'm going to 2021. And then I'm going through with a for loop, basically through the years, and I'm processing each year separately, and then we'll plot them and save them. So first I define the time step by the year from my for loop, and I create basically a little data set that only contains the data from exactly this time step, which means that I'm now solely looking at 2018 and the 1st of January. And I can do this by accessing the biomass sub data set. I'm looking at the variable AGB, the above ground biomass, and I'm selecting the time step, which I define here, and the method is nearest, because not every data is exactly located at the 1st of each month, for example, or some data is has a different time resolution than others. So by using the method nearest, you can assure that you don't run into any error, meaning that if the data set is only available for 31st of December, the day before, then it will take this day. And for the time string, we can give out the time string as well, which I always prefer, and keep it dynamic. I'm also here choosing the time step, so meaning that if in case it is the 31st of December, I will actually see it when I use this in my title, for example. And then we define the latitude and the longitude by accessing the biomass sub lat and long. And then we are already opening the figure using matplotlib, which is this plt command, and creating the axis. And then for the biomass data, there is some data which is below 0, which we are neglecting, which is why we are doing a mask over the biomass data. And then we are using the pcolor mesh command from matplotlib. We basically tell it what is the longitude, what is the latitude, and what is the data we would like to have plotted, which is the masked biomass, meaning only containing positive data points. Then you can also choose the color map. There's various color maps that you can choose from Python. You can even create your own color maps. This is quite easy to do and to Google. And yes, and then we are also defining the color minimum and maximum with the vmin and vmax command. And then for the purpose of having a nice picture for the competition, I'm actually hiding the grids, which would not be something I would do for a scientific publication, for example. But if it's about pictures, then it's actually nicer looking. And I would like to include the text where it shows me which year I'm looking at, which is the command that I'm doing here. And you can define the latitude and longitude once again, where you would like to have the text. And then you can say where the figure should be saved, and then also let it show. So I will now execute this cell, and you can see it's processing 2018, it's processing 2019 and, sorry, I jumped, 2020. And now we have created 3 pictures of the subset biomass dataset. It has created a folder for the biomass, and here you can actually see each different picture. And then in the next cell, I just wanted to give you a quick overview of how you would, for example, create a GIF with those pictures that we just created. So you once again tell it, where are my pictures actually located? You go through each picture in a for loop, and you check that they have the ending PNG. So in case there's any other file in the folder, it will not make any trouble. And then you can create a GIF. So let's execute the cell, and it's actually in the folder above here. With the GIF, you can also define the duration, meaning that how fast the GIF is going through. This is in milliseconds, and you can like increase or decrease depending on what you prefer. Let's have a look at this biomass GIF, and now you can see that it is looping through and showing you the change of biomass over those 3 years. Right, and next I would like to cover one more parameter, which is the land cover. Land cover has its own land cover classification system. You can also find this in the product user guide if you follow the link. There is a specific color code for each type of vegetation or cities, whatever land cover type you have. And I also show them here in the table. And this cell is quite convenient for you because it's basically everything is defined already. So I will execute this. I have here the class IDs. You can see up here there's numbers. Those are the same numbers as in the IDs. You have the class names, for example, needle-leaved, deciduous trees, etc., grassland, and so on. And you have the colors, which are then attributed to the correct vegetation type and land cover type. So we have now defined the colors and the classes, and we can then use this for the plotting. For the land cover, I once again have a data ID that I chose before. It's a ZAR data file. So I can use the ZAR store to open the data just as before. And in the same cell, I'm already building the subspatial subset with the VBox that we defined. And when I execute the cell, we now have the LC sub. You can once again look if it worked. Yes, here we are. Looks good. But the best way to look at the data is anyway to visualize it. So here we are again looping through a couple of years. I took the same range as before, 2018 to 2021. And for the colors, I choose the colors we defined above, which is in this cell. And then let's have a look what they look like. And here you can see that the land cover it's basically exactly as defined in the land cover, what's it called, in the classification style. And you can see the different types of vegetation. If you would like to see the legend, I have put it here. So we can also execute it, and you have actually the legend and could then see what type of land cover we have depicted here. Obviously, you could put the legend further out so you can see more, or you can remove it as I did before. And also here we have 2018, 19, and 2020. And lastly, I would like to point you to some other essential climate variable data, because the competition is about also including different variables. And here we have a list of data sets that you can use for the competition. If you want to look at fire, clouds, land surface temperature, greenhouse gases, or water vapor, for example. Okay, that's it from my side.
Thanks a lot, Lisa. And we're sorry again, everyone, that we have run into these issues. So as I previously mentioned, we will send you a summary with the documentation of how you can onboard on the platform, and hopefully we can manage to get you all ready to use the training environment to do work on it for your submission if you wish to participate in the competition. Maybe we can take a brief 5 minutes just to see if anyone has managed to actually access it, or if you have any questions, whether it is on the onboarding or on the content that Lisa shared. So I will wait and look at the chat to see if there are any questions. So we have a question for you, Lisa. Someone is asking, water bodies were marked blue, but the rivers, I assume, were white in the images that you show.
Let me have a quick look. Yeah, I think the water... Actually, there's water bodies in blue. It might be that the color code is wrong. Good. Well spotted. I will have a look at this and update this in the GitHub in case it's wrong. Because I think those are rivers based on what I remember. And I don't think that the classification has a white color in it. So yeah, I will have a look at it. Thank you.
Thanks, Lisa. We had a few questions on the resolution. We had one question on the resolution of the data, so I answered that. And actually, the operator that Lisa showed allows you to describe the data and have an overview of the temporal description, spatial description. So you have access to this information by using the toolbox operators. So if you have a little bit of time, you can look into the GitHub more into details on the notebook, and then later on, hopefully, if people go into the platform not at the same time, it should be working. We will share the recording of this session. So the code is available on GitHub. So as Lisa was showing, or was it Tonio, you can clone the notebook directly when you are on board the training environment. This information we will share again via email because I know it went quickly, and we still have the recording that we will share to you, so you will be able to do it later. So I will go back to sharing my screen and talk about the competition that we are organizing. And so for those of you who, oh, that's better. Yeah. So I would like to show you a little bit, a brief timeline of how we are planning things for this competition. So today was the training session to understand what type of tools you have in hand to work on your data visualization submission. So the training environment should be working afterwards. So we apologize again for the technical issues. And so we encourage you to use it to access the data in ZAR format instead of having to download each data that you're interested in directly in the platform in .cdf format, which will be much easier if you use this Jupyter Hub. And then we are planning to do a session with the EO experts on Friday. So we will send you a follow-up email to gauge how many people are interested and send a link for this session. If you know you're already interested, you can write it in the chat. So it's very tight in terms of schedule. It's sort of a data visualization sprint. So the registration deadline is really soon. So if you want to do it, you need to register by September 27. And so we'll leave you at least a couple of days to work on your visualization output because the deadline is the latest day of September. And we didn't fix a date yet to when we will announce the winners, but it will be around October. And so maybe I should talk more importantly about what the challenge entails. So the idea is to look at the forest role in a changing climate. So it's not just the Amazon, it can be any forest. So we want you to think about different aspects of how forests are really important in the climate system, and to think how you can translate this into a meaningful message that shows how climate change is affecting forests, or vice versa, how is anthropogenic activities in the forests, so most importantly deforestation, impacting climate change. So you have different ideas that are here underlined that we encourage you to focus on to compute any visualization output that you would like using the datasets that we shared in the Jupyter Hub. And if you want more information on these datasets, you have all the documentation that we shared in the Padlet. I will send you the slides, and so you will have time to digest all this information and to look at all the documentation after this session. So the first point was looking at how forests are a major sink of CO2 and how they're a key regulator of local and regional climate and how they influence the surface energy balance, but also the hydrological system. And so we encourage you to pick any topic that you want, but the key mandatory thing to do is to use, of course, ESA CCI ECV datasets. So it can be the biomass that we shared, it can be vegetation parameters, it can be looking at extreme events and how they are more and more affecting forest areas. So for this, you could think about using land surface temperature, for example. And so we have underlined a few angles on which you might be interested in, but it's just a suggestion. You can look at other things of your interest as long as you're using ESA CCI dataset and you're making a strong link between climate change and forests. So it could be looking at biomass changes over time, the impact of deforestation on emissions. It could be, again, as I mentioned, looking at changes in forests due to rising extreme weather events. It could also be investigating biomass changes with other parameters. So Lisa mentioned that we also had cloud parameters, and it could be a good opportunity to look at the implication for climate feedback loops. So as you see, it's very generalistic. We're not giving you too much information, but we're giving you lots of data set and enough resources to be able to work on your visualization tool. And so we have three categories that we want you to focus on. So you have to choose one of these categories. So it can be either a static image, an infographic with a clear and impactful image. It can be an animated output. So it could be in the form of an Instagram or YouTube short. Or a time lapse that shows changes over time. And it can be also an interactive output, so in the form of a dashboard, for example, or a scrollable story. So you can be creative with this. And so you might want to know why you should join. So of course there are prizes, but most importantly, it is the occasion for you to showcase your data visualization skills and also learn more about ESA's Climate Change Initiative data, as we've done today. And in the session with experts on the 27th, you will have the opportunity to exchange with them. And of course, you can email us if you have any questions on the data, and we will try as much as possible to forward your questions to our expert scientists. It's also, the ambition is also to share the winners' output ahead of COP30 in the ESA, Climate ESA social media. So it's also a way to encourage climate action with data storytelling. And lastly, I know it's not the one that interests you the most, but the prize is going to visit the FEE experience, which is ESA's Earth Observation Multimedia Center located at Esrin in Italy. So we will offer you a tour, all expense paid for the winner. So how will this winner be selected? It will be selected by a jury consisting of science experts, communicators, and ESA staff. So who can enter? So unfortunately, participants need to be nationals from an ESA member state or an associate state. It is only open to these nationals, so you can check on the website to see if your country is part of these member states or associate states. The flags are actually below, so you can see if your flag is in it. And you have to be 18 years and above. So group submissions are accepted. There are no limits to the submissions number. So I saw a question on the chat about this. So you can submit as many as you want, but they all must respect the criteria, so that they use at least one ESA CCI ECV source, that we have a strong message that links climate change and forest, and we will also judge the aesthetic and shareability of the visualization. And so how to submit your work? So we have a Dropbox link that is in the Padlet. So again, there will be a recap email that will include all these links. So we request that you group the visualization output with Jupyter notebook, or if you are not using a Jupyter notebook, it could be a text format or a README file in Markdown, for example, that clearly shows how you computed the visualization output, and also mention the CCI data that you used and any auxiliary data that were used to do this computation. And so if you've used external environment or libraries, it has to be included in the information that you put in this Markdown or notebook. And all the file that you used needs to be combined in a compressed folder. So all this information you can find on the website, and you can submit it on a Dropbox. So if you plan on doing multiple submission, you can. You just have to add the number of submission that you do. So your first submission will be / submission 1, 2, etc., all in compressed formats. And so I will end this here, and I will take questions before moving to the last part of our presentation. Yes, but then so there was a question, can you have a group submission with participants from a non-member country? Yes, but then the person who will be able to travel to the PhilLab experience will have to be a national. So the submission will be on the name of the ESA of the citizen of an ESA member state. What about outside EU? So there are actually member states that are outside the EU, such as the UK, for example. So you just have to check that your country is included. Switzerland also is included, and Canada is included. I think that's all for the questions. Asia, no, unfortunately, no. I'm sorry about that. In the future, we hope to make a competition more open to all. Yeah, so that's, I'm currently. So yes, so I encourage you to check on the website if your country of nationality is a member state, to confirm if you're able to participate or not. And again, if you do a group submission with multiple nationals, you have to have a lead for the group submission, and this one has to be a national of an ESA member state or an associate state. Can we submit for learning purposes if we're outside? I don't see a reason why not, but then because of the requirements and the rules, we will not be able to select you in the process for the winners. So you could submit if you would like to. Yes. And that's it for the questions. I believe if you have any more questions, I will respond in the chat. And because we are tight for the schedule, I propose that we have the last presentation, which is on effective guidelines for communication, science communication. And for this, I will stop sharing my screen and I will open the floor to Jana, who is from Klein & Hirsch, an expert in communication. So Jana, the floor is yours.
Thank you very much, and hello everyone. I try to share my screen with you.
We can see it.
Can you see everything?
Well, we can see only the slides, yes.
Perfect. So, yeah, hello everyone. My name is Jana. I work at Klein & Hirsch, and I am a consultant for change in science and sustainability communication. And today I'd like to share some insights into storytelling and explain why we think it's important for scientific communication, whether it's for presentation, text, or visualizations. Let's start with a look at our brain. Dr. Yuri Hassan is a neuroscientist who has studied how the brain works. He discovered that when people are presented with only data and facts, only 2 areas of the brain are activated, and you can see this here. The brain is pretty sleepy and not very active. However, our aim is to enable the audience to absorb as much of the information we provide as possible. We can actively achieve this goal more effectively by conveying information through stories. So when stories, different areas of the brain become active. For example, just listening to a phrase like, when I walk past the bakery in the morning and the smell of warm croissant and fresh coffee wafts into my nose, makes your mouth water, right? So stories create a completely different perception and level of attention in our listeners. And this applies to oral narratives, to lectures, written texts, and infographics and visuals alike. The audience can remember the information more easily, and it can be retrieved more quickly and for longer as well. There are a couple of general things I want to point out to help you guide to tell a good story with when you decide to enter the competition. With all these points, please keep in mind your audience is your guiding factor, and you know best who you want to reach. And this is the number one thing you should focus on. But first, keep it short and simple. Humans can only hold 5 to 9 pieces of information in short-term memory and this is especially true when being in the digital space. So the more your design or your story demands from working memory, the more users tend to feel overwhelmed or confused. So keeping it as simple as possible and chunking information into digestible bits helps reducing cognitive overload and improving retention. And of course, simple for the general public means something different than simple for the scientific community. So, as I said in the beginning, please keep your audience in mind. Secondly, try to evoke emotions. Storytelling with emotions will help us to better inspire and engage with our audience on the scientific topics, and this is especially important when we are talking about climate change. And there are many different ways to achieve this. One is the use of figurative speech. So a lot of you know the power of visuals from a professional standpoint, so this is nothing new. We think visually. The way to our hearts and minds is through our eyes. Seeing and feeling go hand in hand. Because of this, visual language is a powerful form of communication. The concept of figurative language is not limited to rhetorical flourishes like metaphors or comparisons. You can evoke a strong emotional reaction or response in your audience if you manage to use rhetorical images to create associations with their memories or their feelings. A second point are practical examples. They tend to lend heart and soul to your narrative. They make the story more tangible, memorable, credible. Authenticity will always rise above the deluge, is that the word, of information we face in the modern world. Weaving real life examples into your storytelling enables you to share experiences and by addressing your audience's problems and desires and by bringing them to life to connect with them on a more emotional level. And last but not least, the story of self. The story of self is a concept about sharing a personal anecdote or tale with the audience that illustrates your feelings and experiences with the issue at hand. By disclosing some personal information to your audience, you create a safe space in which others can tap into their own feelings. You will also gain more credibility and attract more trust through sharing your experiences. This concept is particularly useful for talks and presentations, but it works for other formats as well. So it might be very useful for you to have a look into this. Because in the end, people trust people and they seek connection. And in essence, the story of self sets out the personal experience and moments you associate with your concern, at a very personal level. And finally, be specific. I know it's hard when you have a lot of data at hand, but focus on the most important thing, the news itself, the news you want to tell. Think about the key points of your specific audience in advance and stick to them. For a good story to succeed, you will have to make wise use of details, data, facts, and background information. And here's a very simple example of what I mean by that. There are 7 volumes to the Harry Potter saga, and each of them is pretty long. So when you asked AI to demonstrate that you can relate the narrative of these 7 volumes in 20 seconds, or even boil it down to just 1 sentence. But of course, this is only possible if you stick to the very bare essentials, and if you know what essentials you want to focus on. This means that you become increasingly restricted in the use of details and additional facts to explain your concern. Generally, the principle less is more can be very helpful advice for science communication. And we are all pretty familiar with the situation. As listeners, we all have trouble remembering too many details, and this is also true in the digital space. So people tend to switch off and no longer listen to explanations or read about them. So when you're bombarded with more background information and too many figures and insights and examples. So depending on your format and your audience, it may be better to select just 1, 2, or 3 details that ideally emphasize the point you want to get across, or to a detail that seems best to persuade your audience, and leaving out all the rest. To conclude, I would like to briefly summarize the 4 core elements for compelling storytelling. First, show your audience what is in it for them. Consistently focus your story on your target group, their experiences, their needs, knowledge, specific challenges, etc. Second, take the time to structure your story. Develop a narrative that is easy to understand, easy to follow, and will capture your audience attention. Third, use numbers, facts, and background information wisely. When it comes to telling a good story, a narrative, less is often more. Just tell them what they need to know to understand your message, and you can provide additional information in other ways. And finally, tap into emotions. To build relationships with your audience, a good story must also evoke emotions. A visual language, real-life examples, or maybe even a story about yourself might be techniques that will help you achieve this. And that already concludes my brief excursion into the importance of storytelling. I hope it has helped or inspired some of you to look a little bit more deeply into the storytelling aspect. So thank you for your attention.
Thanks a lot, Jana. Are there any questions for Jana? We will also be sharing your slides after the session, and I will share a link in the chat, which is the Padlet. So you have positive comments, Jana, in the chat. I'm sharing the Padlet where you will have all the documentation stored, including the slides that Jana has presented that I will add later, and the slide that I presented. So with this, I think we are concluding storytelling is a skill or not? That's a question.
Yeah, it's definitely a skill, but it's something everyone can learn, and it's done by practice. And you can start with just a small aspect. I know I bombarded you with a lot of different nuggets, but showing a little bit more thinking from your audience might be the greatest first step.
And major difference between story and research facts.
Well, in science communication, research facts have to be the basis. But I'm a firm believer that if we want to reach a broader audience, and even the scientific community, storytelling is a very useful skill to have, so people actually remember the stuff you want to tell them.
And for the competition, do you have any specific advice to give to the participants in terms of what would be specifically striking for the challenge that we suggested?
That's a difficult question.
It is a very broad one.
But I think we have such great data sets available. So making sure that you can tell a story with the data and having something that is personally striking to you so you can convey it in a compelling way, and keeping it as simple as possible so people can actually understand it. I think that would be my greatest advice.
Thank you, Jana.